Okay, today we're going to be talking about derivatives, and we've been talking about them for a while, and what we're specifically going to be talking about is the chain rule and the power rule and how they are kind of similar to each other and how they kind of correlate with each other. Now, on this slide, we have a definition of the derivative, and this top one is the definition using the limits, and we've learned how to take derivatives using this. And the derivative is just, it's a measure of how a function changes as the input changes as well. So this is talking about the x. Here for the chain rule, we have x plus 3 all cubed. Now the first step is to take the 3 down, and then take it out front and multiply it, and reduce the exponent by 1 and multiply by the derivative of the middle. So we have 3 times x plus 3 all squared times 1, so it's just 3 times x plus 2 squared. Here this example is 4 times x squared minus 4x all squared. So we do the same thing, take the 2 down, keep the middle the same, reduce the exponent by 1, multiply by the derivative of the middle. So we have 8 times x squared minus 4x times 2x minus 4. So we can just write it that way, take out the multiplication. Here on this, we have the power rule. It's just 4x cubed. So we take the 3 down, multiply it, so it's 3 times 4x to the 3 minus 1 times the derivative of x. So it's 12x squared times 1, or just 12x squared. Now if we take a quick look at this, if we notice something, here's the derivative of 4x cubed just using the power rule. It's 12x squared. On that last slide, we did the derivative using the chain rule. We got the same answer. We just take the 3 down, multiply the 4, and it's an x squared, so it's 12x squared. So is the power rule the chain rule in disguise? Well, the simple answer is yes. The chain rule is the power rule in disguise, and the power rule is the chain rule in disguise as well. I hope you learned something today.